Hi everyone. So today the paper I want to share is the Mask Regional Convolutional Neural Network, which was done by the Facebook AI Research Group. And the main problem they want to solve is the instance segmentation problem, which has been the important task in the computer vision for quite a long time. So I will first introduce its structure and also some basic stuff like the dataset it used and how much time it used for training. And also I want to point out two highlights of this paper, which caused the result of the instance segmentation was super well. So this paper was released on this April 5th, and I think it's quite famous because I search on the GitHub, and there are like TensorFlow and PyTorch implementation of this paper. But these two repositories are still in the process, so it's not like complete yet, and still many open issue. So yeah, after I do the brief introduction of this paper, I also want to do a simple demo on the Jupyter Notebook. Yep. So first we can just see the result, which was like super good. It's just like a ground truth. It was like amazing. And we could see that you could mark the people with different color. It means that instance segmentation, which was mainly different from the semantic segmentation. The instance segmentation can mark the object within the classes with different color. So you could see that people, but different color, umbrella, different color, the bags, different color, and here like cars, different color, and so on. Yeah. So okay, I'll first introduce is network look like, which I will mainly compare with the faster RCNN, because faster RCNN is famous using on the box detection and also the classification. But Facebook, based on this network, and at a parallel park of the mask, generate a binary mask, and then it could generate a generate the instance segmentation result. So since there are a bunch of tutorial or blog or slides introducing this paper, so I just screenshot the one I feel could explain the idea pretty clear, and I screenshot these slides from the UNI Freiburg University, which was a university in the German. And so we could see the network looks like this, and here is MaskRCNN. So you can imagine if it is faster RCNN, you just remove the part of the mask branch. So it will look like here, and without the mask branch would be the faster RCNN. So we could see the whole branch is look like first you have the images, and after the network could get the feature map. And based on the region proposal network, we could get some regions of interest. And then after the region of interest alignment layer, we could get the extracted feature map. And then based on this feature map, we could do two parallel, and one is just like a fast RCNN and do the box regression and the classification result. And the other branch we will do the binary mask in order to generate the instance segmentation result. Yeah, so that is basically its network look like. And the data set it used is the COCO dataset, which was developed by the Microsoft. And in the end, I will talk about the training time or something, but here I want to highlight two parts that make the result like super well. So here I just saying that it had a branch for predicting segmentation mask. Yeah, and so the first highlight is it fixed the misalignment on the region of interest pooling. So I do a simple experimentation. I screenshot some explanation on this idea, and it's also from the screenshot of the university in German. So we could see that in the original list part, region of interest alignment layer, actually in the faster RCNN is region of interest pooling. So the main difference is one does not do the quantization, but the other one does do the quantization. And like in the original region of interest pooling, it do the quantization, which will decrease the accuracy during the instance segmentation. So Facebook here modified the original pooling into equal the region of interest alignment, which means that when they output the region of interest, and it does not do the quantization like 2.7, it will remain 2.7, it will not go to 3 or 2. So here is a pretty good example on explain the idea. So in the original idea, if we have a region of interest like in this region, and even we calculate a line like 2.4, 2.5, and 3.5, we could still cut like in the 2 and the 3. So after the max pooling, we will get this result. Like this region, the maximum is 0.85, and like in this region, the max number is 0.97. So you can see this result. But like in the MaskRCNN, if we calculate like 2.5 and 3.5, we could just put a line in here. But how do we get the result in this small region? So the idea it used is using the bilinear interpolation. So you can see here. And I think the idea is just like, you can imagine like 0.85, it takes maybe like, I don't know, maybe like 2/5 ratio of this subregion, and like 0.34 maybe take over like 1 or 2/5 ratio in this subregion, and then you calculate, you multiply by their ratio and then sum it up, then you can get the result like this, and then do the max pooling, you can get the result. Yeah, so this is one mainly different from the fast RCNN. So it's this part. The process from the ROI to the extracted feature map, one do the quantization, but the other doesn't do the quantization. Yeah. And so here we can see in the paper, it says that this is the quantization free layer, so called the region of interest alignment, and which are pretty amazing that it has a pretty large impact and improve the math accuracy for about 40%, like from 10 to 50. So it's a pretty good. And the second highlight is it do the parallel. So it means that it doesn't do the classification based on the mask result, but in the other way, they do mask and classification in parallel. So you can see, go back to see the network. The mask result is based on the extracted feature map, and the classification and the box regression is also based on the extracted feature map. So the classification and the mask branch actually they are decoupled. They doesn't the result of the mask does not generate from the classification result, and the classification result does not generate from the mask branch. So why they do this one? I think they just because the experiment result, because they say that if we predict the mask for each class independently, and they didn't predict the mask based on the classes, or it doesn't predict the match among the classes, it will improve the accuracy. So we can go down here to see that the result is super good. Where is it? So yeah, here. So we can see that here. So is it here? Sorry. here's some part that talk about the accuracy. Decouple. Oh yeah, sorry. So like softmax here is the usually used in the fully convolutional neural network, which is the um, method on generate the semantic segmentation. And the sigmoid here we could see is a per pixel sigmoid in the binary loss. So it generated a mask for each class without competition among classes, and it did improve the average precision about like 5 points. So it's pretty good. And yeah, so this is another point. It says that if you decouple the classification and the mask generation, it will improve the average precision. Yeah. Okay. So I think the paper mainly just focus on modify the faster RCN and highlight these two parts. Yeah. So I think I will not go into detail on the RCN and fast RCN or faster RCN because it just yeah, too many words. Okay. So yeah, I just say that decouple mask and class prediction. Oh yeah, and also one point I want to say is that it's pretty smart. Like it defined the loss because loss is like multitask. It combined with the class, combined with the boxes, the bounding box, and will combine with the mask. But the loss of the mask is only defined on the ground truth mask. What does it mean? It means that, so suppose that here are a couple of regions of interest, and it generates mask for each classes on one region of interest. So it doesn't means that it only generate the classified classes mask. It generate for example, you have K classes candidate, and it just generate K mask for one region of interest. But because we well know the ground truth, right? So if we know the ground truth is the K minus 1 class, then we will only mark this mask consider into the loss. We will not consider the other K minus 1 classes into the loss of the mask. So this will help us to generate the help us network to generate a mask or something. And yeah, so we rely on but how do we pick up the mask? We rely on the detected classification branch. So this branch is like here. So here the classification result will help us to pick out the mask we want. And so the idea is just we generate a mask for class but without competition within the classes. Yeah. And yeah. So there are also some detail on the head on the backbone, which means like how it extract the feature map. So there are two ways. One is based on the residual network, and the other is combined with the feature pyramid network. So it seems that the result of combining with the feature pyramid network works well. So like you can see here, like residual net and combined with the feature pyramid network, and the average precision is better. Yeah, so I think that's the main point in this paper. And finally, I want to talk about the chaining. So actually, it takes not so many time on chaining, and if you want to just do prototyping, you can just complete like in a day if you only use the chain set. Yeah. Oh, and there's another point I felt really interesting because I felt like this network is really flexible. You could even apply it on the human pose estimation, which was pretty amazing. So we could imagine like in here, if you have K classes, now you could imagine these classes are the number of landmark on the body. So if you have like left elbow, left shoulder, right shoulder, like there are 16 points you want to detect on the body, then the classes number is 16. So you just interpret the classes into the landmark, K key point or key point, somebody say key points. So yeah, in the others, I think evaluation might be different, but mainly the network will stay the same. So yeah, and we could see the result is also pretty good. So you could see that people, they have then key points on their body. Yeah, and so this one is super good. Like so many people, but you could still circle do the instance segmentation, but also the human pose estimation. Yeah. Okay. So I think that's the main point. Like the network is mainly modified from the MaskRCNN, and like two highlight. One highlight is for it decouple the mask generation and the classification, and the other highlight is it modify the region of interest pooling into the region of interest alignment, which improve the accuracy on doing the segmentation. Yeah. So okay, I'll quick do a simple demo, which was I modified a little bit on the TensorFlow implementation because when you just git clone from the implementation, like this implementation, where is it? Oh yeah, here this one. So there are some bugs for you to produce the mask or something, and there are still so many open issues in this repository. So I modified a little bit in the code, and finally it could run. So I'm to just simple demo. If you're interested, you could just git clone this repository and run it yourself. Okay, so yeah, I'll first run it and later tell what it goes. So here I modify a little bit on the trend.py and okay. So yeah, so it's still running. It starts to run. So first simple say, and later the result it will be put into here. So now it's still empty, but we could later see how it goes. So first load the data and load the network, and mainly the network of like how to calculate the class loss, the box loss, and also the mask loss is in this pyramid network.py. And after we calculate, we could save the result in the output dictionary, so we could pick out some result we want to from the dictionary. And later you could restore here to import your pre-trained parameters from here. And the pre-trained model I use is I trained around like 4,000 iteration, but because my storage on the GCP is not pretty big, so I actually minimized the data set, like only like 2.2 gigabytes on the training set. So it's quite small. So yeah, I have to say that the result later show is not pretty good. It's not even close to the paper result. But I just want to show the idea that you could detect a box, you could detect a class, and you could even detect some part of the mask. Even the mask is not pretty accurate. Yeah. But just for prototyping, I want to show the idea. So here now the loops start to go, and here is the main part. So here I will draw the mask on the object, and here is the ground truth. So actually, I'm not like write these by my own. Actually, there are so many open issues, and I just saw somebody write this one, and I also modify a little bit because there are some buggies in it. So finally, it works. So let's see if there is any result come out. Um, oh yeah, here. Okay. So the reason why I didn't save each images is because not every images has a pretty good result. Some even doesn't have any mask on the result. So let's see how it goes. Hopefully it will not too bad. Okay, let's see. So here's the result, like so many boxes, but we can zoom in to see, yeah, it's a person and it also has a mask on it. And we could see the ground truth, how it looks like. So it looks like this. And the test result is like this. Yeah, so maybe like this person, the mask is broken, but this one, yeah, a little bit close, but still not pretty well. Okay, so that's it. This is my sharing of the mask regional convolutional neural network. I hope if you have any problem, you could just um, tell me, and I hope you will like have a great concept of how the instance segmentation works. And I have to say that result is super well. I expect that Facebook maybe someday release their code or something. Yeah, so thank you.